Recording. Okay, so let's get rid of this. Okay, so today's session is on unpacking the new math curriculum, grade 4 number, and we're specifically going to be dealing with fractions today. So just before we get started, we'll do the land acknowledgement. I'll just get that chat. Okay, that's great if you want to stay. Perfectly fine. Thank you. In the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional treaty lands across the province of Alberta, home to many diverse Indigenous, Métis, and Inuit peoples. Okay, usually when I start, I usually start with a warm-up. This one has to do with fractions because we're going to be dealing with fractions. So what I'm going to do today is I'm going to show you the math talk or the math warm-up. And I have done this a few times, so I'm just going to give you some of the answers that I got. You can think about your own answers if you want, but I'm going to share with you some of the responses I got from some of the students that I worked with. And one of them, the first one, is particularly very good. So the question is, when is it better to have 1/4 or 1/4 of something than to have 3/4 or 3/4 of something? And so the idea is you look at this, you've got a visual here, and obviously it looks like in equal parts that 3/4 is bigger or more or larger than more than 1/4. But when is it better to have 1/4 of something? And so the idea is that you would think about that, come up with some responses. And here are some of the ones that I got. So I'm going to share those in this way today. And this was my favorite because I don't like liver either. And that's what a student said. When I have to eat only 1/4 of a piece of liver instead of the full piece, because I'm not a liver fan either. Obviously, it was a young boy, and he had to eat his liver at home, but didn't like it. So he said that was better. 1/4 there was better. When it's $250,000 and not $750 $100. When I only have 1/4 or 1/4 of my homework left to do, it's better. And when I have 1/4 or 1/4 of $100 instead of 3/4 of $10. And there were other responses too, but the idea is for them, because they're going to see that 3/4 visually and in math is greater than, but in real life, is it better to have maybe a smaller number of something? So that's just a little warm up for you. This is what I'm going to be doing today. I'm going to share the understanding of the outcomes. In grade 4, there are 2 clusters of outcomes. And the consortium, if you're not familiar with the documents, the consortium has, the Alberta consortiums have coded the outcomes. They are not coded from Alberta Learning, but they are from the consortium, only because they come in clusters, some of the outcomes. So we have 2 outcomes, the same outcome. I'm going to correct myself. It's the same outcome. Students apply equivalence to the interpretation of fractions, but there are different clusters. One is going to be dealing with fractions in itself, comparing them, and the other one is going to be dealing, an equivalence, and the other one is going to be dealing with fractions and decimals. And then the other learning outcome will be 4 and 6, which is students interpret percentages. And we include percentages in here because it deals with fractions and decimals as well. I am going to be talking about towards the end, some misconceptions and misunderstandings that you are going to see where you might have this misconception even yourself, but may not know that. And something as simple as an example, and it's not really a misconception, but it's what we might say in classroom. And that's why when you heard me say the question 1/4 or 1/4, we have to be very aware of where those students have come from and if they've said 1/4 or did they say 1/4, and what's more comfortable. Neither one of them is wrong. You have to just make sure that you the students know that both of those, quarter and fourth, mean the same thing. So I'll just read this and then speak to why I put this. One of the most important things we can do as math teachers is to constantly deepen our understanding of the concepts our students are learning. And I know that we feel that sometimes grade 4, 5, and 6, or elementary in general, we know the math. It's not difficult for us to do the math, but my passion, my interest is in making sure that as teachers and educators that we understand the math. And it is easy to understand in many circumstances, in many ways, but to really understand it and really know it intuitively, because if we know the content and we have a good relationship with our students, we can spot where there'll be struggles or difficulties or strengths or creative thinking or deep thinking. But you really do have to have a very good intuitive internal knowledge of the math behind the learning outcome or the concept. And that's why I always put this there. So what you're going to get today is you will get a sense of what those outcomes mean. There is going to, I'm going to post the second session that follows this one, where you're going to actually get into more really teaching strategies, tips and tricks that you can do with the students with fractions. But this session is more looking at, do you really understand what those knowledge and understanding statements mean and what they're all about and the math behind them? So I'm going to start with some very quick resources. Every session, there's always sites, and these sites you can see. Some of them will be similar if you've been to my sessions. The top ones are always the same. It's the Learn Alberta, it's the ARPDC sites website with the documents. And then I always try to find things that deal with whatever concept or learning outcome. So there are two sites with this, for this sites, for the dealing with fractions. And then these are some general professional learning resources. What I always do is usually show anything. I will show something from ARPDC or some document from Learn Alberta. You will get those in your notes. But for today, I won't show them because some of you have seen them many times. They will be in the slides that you will get. If there's any document from Learn Alberta or from ARPDC, any other professional learning document that deals with fractions, you'll be sure to get those. Sometimes I put the yearly planner up so that you can see where you teach fractions in 1 month, in what month you should be teaching them. So these are some professional learning resources for you. They're teacher resources. And then there's some literature. And fractions and literature, math and literature, for me is really another great interest of mine. So these are some books at your level. They don't get fooled by the cover, because like Fraction Fun may look like it's for primary, but it's not. And the circumference books, Circumference and the Fraction Fair, Fracton Fair, is not all of that book will be applicable to your students, but the premise of it is really good. Spaghetti and Meatballs, great. It shows fractions in many ways. So these are just some of them. And then there'll be another book that I'm going to include there that deals with decimals. So this just some resources for you. Okay, so we'll look at the bridging. Because we're going to talk about grade 3, because your students have they've come from the new grade 3 program with a basic understanding of fractions, but we're going to have a look at that because there was so much that was new to grade 3 last year that we can't be guaranteed that these students, and you have them this year, you've had them for a month at least, whether they'll know everything there is, all the prior knowledge about fractions. So looking at the bridging document from Alberta Learning, we do know that in grade 4 that the students will have come from some knowledge of grade 3 of what a unit fraction is. I'm looking at that last column, suggestions to support the bridging, because they will have worked with unit fractions. We're going to talk about that a little bit, but you're going to have to do some practice with naming fractions. And I think and writing fractions, I think it's just, you need that review. You need to find out what those students really know and what they're understanding from the new grade 3 fractions, because this year in grade 4 they're going to be dealing with. It's quite a bit for grade 4, I feel, because we're looking at equivalence. We're looking at simplifying fractions. And that's going to take some work. So you really want to give those students a really good understanding, basic foundational understanding of fractions. And you yourself will have to have that knowledge, things like what a unit fraction is, and feel comfortable with it. I'm going to just show you, this is very quick. The reason I wanted to show you this is because of the resource that goes with it. So we're going to look at the learning progression for fractions and versus the curriculum progression. So the learning progressions are the natural flow and order of how we would teach fractions, starting from the small grades or the lower grades, right up until we're doing operations, multiplication and division of fractions into the grade 6 and in the junior high. A learning progression is like the ones that they use. Mathology has one. Dr. Lynn McGarvey from the U of A has, through Pearson, has written a tremendous resource on the learning progressions for all of number. And it is the learning outcomes, but what it is, it's like they've taken them apart and unpacked them into very small attributes. And it's like, as I said, the flow of learning. This particular site, and the reason I want to show it to you is because a great resource is from the Department of Education or the Ministry of in Ontario. When we talk about learning progressions, it's generic. It doesn't belong to a curriculum per se. It belongs to a flow or a progression of learning in general. And so the fractions learning pathways that they made from the site is called EduGains, but it is from the Ministry of Education in Ontario. So this green part is the unit fractions, and that's where we just talk about fractions. And then there is the second part, where they look to compare fractions, equivalent fractions, and then the second part is the operations of fractions. So that's kind of like the flow, and each one of these boxes will have some activities. Now, the idea is that if you're going to use this site, that you can click on any one of these boxes. So when you go to this particular site and you're dealing with comparing fractions, let's say in this blue area, or comparing fractions with like denominators using models and symbols in this blue area again with the D, what you can do is click on any of those boxes. So whatever you're working on in grade 4, you can click on one of those boxes, which I'm not going to do here, and up will come a series of activities for you. And some of them are short and quick. Some of them are lessons. So here is, I clicked on comparison A, the blue, comparing fractions. So on this page, when you go to this site, you'll get lessons and support, there's practice, there's home support, and then there are activities and tasks for you that you can do with your students. So this is a background that we'll talk about. This one says generating recognize equivalent fractions using models and symbols. So that's falls under this particular comparison, comparing fractions. There's an explanation, there's visuals, and then there's activities. So there's one here called recipe task, and then there's one here that I just kind of enlarged for you called equivalency comparison. And it's actually making these, you can see the graphic here, it's making these rectangles and doing some shading with the students. It is a very good site. So it follows, because it is generic, it follows our new curriculum, and you've got the site for it, and it's just a really good added resource for you. So I'm going to look now at reviewing the prior knowledge, and it goes with the grade 3 because it's something that the students are going to have to know in order to work with the grade 4. So this is just a table of the actual grade 3 learning outcomes, so that you know, if you have not looked at the grade 3 or have not started fractions yet, so you will know what these students should be coming with, what some of them will be coming understanding, what some understanding they'll be coming with, or maybe a lot. So in grade 3, the knowledge was the prior knowledge coming from grade 3 is that they would have to know what a fraction was, that it is part of a region or lengths, or it's part of a set or a quantity, and that equal parts of each equal group, that they can represent, equal parts of each equal group in one whole quantity. So that just means that they should be able to take and we always use circles or pizzas, that they should be able to take a region and divide it up into equal parts, take a set and divide it up into equal groups, and to be able to identify them. They need to be able to name the fraction. And this is the one thing that's new in our curriculum, and something that the grade 3s hopefully will come with, is what a unit fraction is. Now, we know what a unit fraction is. It is the 1/5, 1/4, 1/4. But what they do in the grade 3 curriculum is they go into it a little deeper, that anything that's divided into equal groups, one of those is called a unit fraction, and two of those are 2-unit fractions. And we're going to look at that in a few slides. But it does say here, a unit fraction describes the size of the equal parts. So very simply, if you've got something that's divided into quarters or fourths, one of those, the unit fraction, is 1/4, and 2 1/4 would be 2/4, and we'll talk about that. So they dig deep a lot into that. What does that unit fraction mean? I'm going to say it now. If I miss it later on, everybody does shaded. What part is shaded? What part is not shaded? It's really important for you to understand and say to yourself all the time that every visual that I have, be it a circle or a bar or a group, there are always 2 fractions. We always ask what fraction is shaded, but there's also the fraction that's not shaded, and that's really important. And if I don't bring it up again, you have to remember that every visual that you see, there's always 2 fractions, the part that's shaded and the part that's not shaded. And that's really important, because that really brings into play the whole, because we have 2/5 and 3/5, and when we're adding fractions. The other thing grade 3s are coming with is, or they should know, is the fraction notation. So how you write that fraction, what it looks like, what it means, that there's a quantity on the top and there's a quantity on the bottom. And it's just not, it is a number, that's exactly right. But those numbers, the top number has a meaning, a number of equal parts, and the denominator is the total number of equal parts. So the number of equal parts on the top may be the part we're talking about that's shaded, or the set that we've got in our hand, or the up to a certain point on the number line, and then the bottom is the whole. And they talk about that a lot, so it's just not a number, a line, and a number. And then they talk about equal numerators or equal denominators, and how they can use those for comparison. So if you have an equal numerator, 2/6 and 2/4, which one is greater? Would you rather have 2 pieces out of 6, or would you rather have 2 out of 4? And the same thing with the denominator. And you talk to them about that, and they have had that, 2 out of 7 and 4 out of 7. That's a little easier, because having 4 out of 7 pieces, equal pieces, is better than having 2 out of 7 equal pieces, or it's greater than. But you can see that that's part of the grade 3. So if your students are not there yet, you're going to have to go back and do some review with them. And then they learn in grade 3 that where the numerator and the denominator are the same, that it makes one whole. And they hopefully had some visuals with it. They've also worked with the fraction on a number line. Very simple fractions in grade 3. They do go to, I believe they go to 12ths in grade 3. It might only be tenths. But when you do it on a number line, you're looking at 1/2, 1/4, things that are easy, fractions that they're familiar with, hopefully. And then the understandings, the part to whole relationship. The difficult one that students most struggle with is the set. They see the whole circle, they see the whole rectangle. It's the groups, the grouping or the set, that is a little bit more of a struggle for grade 3. So there's the knowledge and the understanding. And these are all the things in grade 3 that they should have been able to do. So model a fraction as a region, as a set on a number line, and it is denominators of 12. Identify the numerator and the denominator, be able to use those terms. Hopefully they've used that vocabulary through math walls or anchor charts. They have to be able to name a given fractions up to 12s, and don't assume because the number is at the top that they're going to say the top number first. What that line means, because there's no word for the line. We're saying 7/12 or 3/5. We're not saying 3 to 5 or 3/5 at this point with the students. So they see that line and they're not sure. You have to practice with them. And then they're going to have to do greater than or less than. And again, in grade 3, that was when the numerator was the same. And then when the denominator is the same. And hopefully they've had lots of visuals. But you, again, if they don't come with this prior knowledge, you're going to have to do some work with them on that. I missed one. No, I guess it's coming later. Okay, because there is the prior knowledge of grade 3, but there is going to be some prior knowledge even within grade 4 that you're going to have to work with, but that's on a further slide. So these are just some slides, and I won't go through them because they're mainly review. So they're looking at that prior knowledge. So you can go through these slides. What is a fraction? And I know that's simple, like you're thinking, well, I know what a fraction is, but just like the mathematical terms associated, what does it really mean? What do you think when a student sees that? What are they going to say? So there's information about the parts. What does the top number mean? What does the bottom number mean? And determining the whole is important when working with fraction. And that's that numerator or that bottom number. That's critical. That's the first thing that you're going to start with. How many do I have altogether? How many equal pieces? And as much as you can, you're going to say equal all the time. How many equal pieces and how many equal sets? Now, I am going to bring this up later on, but I'm going to show you. This is not the best visual because you're going to see me. I have written the fractions like this because oftentimes I'm a little bit lazy and I don't go to my math, the part where I do the math symbols. And sometimes I just use the slash on the keyboard. I'm going to highly suggest, and not so much for grade 4, but when I work with junior highs right now as well. I'm volunteering, and I tend on the whiteboard, if I need to do something quicker on the mini whiteboard, I have a tendency to do the slash. And even with the junior highs, I catch myself and I say to them, don't do what I do. So I'm going to caution you. I know that this is very easy to do the slash. And again, some students, when they see that slash, that's a 2 right beside the 1. So that doesn't even look like a fraction to some students. Just be aware of it, that if you are doing a very quick fraction on the whiteboard, I would assume that 4 to 6 teachers wouldn't do that though, but I have done it. So this is just to let you know what is a fraction, and then some critical understandings. So a fraction is a number. That's really important for them to do. Sometimes we say fraction number, but they need to know that it is a number. That fractions can be interpreted as parts of a whole, a region, an area, parts of a set, a measure, or a point on a number line, and the measure is the distance. So for a fraction, it's division. That line, when they get through 4, 5, and 6, the students are going to progress to looking at fraction as a quotient, so that they're going to have to divide the two numbers. It's a ratio, and it's an operator. And that operator is for the higher grades where it's half the size or 3/4 of something. But yet in everyday life, your students have, we've used that phrase all the time, half the size or 3/4 of something, like 3/4 of $100 or 3/4 of a glass of milk or something. But in the curriculum, we're going to focus mainly on the region, on the number line, which is the distance, and on the set. And they can be represented as fractions, as decimals, and percentages, and all 3 are related. That That's the second cluster is going to deal with the fractions and decimal, and the second outcome in grade 4 deals with percentages, but they all are related. Remember that visuals are important. The number lines are key. In the new curriculum, all throughout 4 to 6, it's written in there that they have to represent, maybe model, but number line is used quite extensively. And money is a really good manipulative to use for fractions. And when we get into decimals, I did the decimal session already and working with decimals, and we talked about money a lot. So there's an example of using it on the number line. Now, this is, you're going to see this again, but this is, I'm going to point this out each time. You can see that, and very important to know and be aware when you're teaching it. When you're doing of a region or an area, it's very obvious that there's equal pieces, but the equal size parts. But when you're doing it of a set, it does not have to be equal size. So sometimes we have a tendency to always focus on that size all the time, equal sides, equal parts. And then we get to something like this where it doesn't have to be that. And that's really sometimes it's difficult for kids to switch on to that and then go between the two all the time. So those are things for you to remember. Now, this is just, again, a quick slide. I'll have to maybe not read so much, but because it's easy for you to see. This is just what a unit fractions. It's any fraction with a numerator of 1. It represents the base unit of any fractional amount. So we start with that 1/5. That's the base unit. Even when we get to the circle and it shows 2/4 of that, or 2/4 of that circle are shaded, we want to know what that base unit is, which is 1/4 or 1/4. Any fraction can be decomposed using unit fractions. And then I'm going to show you on the number line that you can even count this way. I know it's a little cumbersome. It's not something that I ever did when I taught, but I can see now that I would use this quite a bit. So we have 1/5. And then if we went here, we have 2 1/5, 3 1/5, 4 1/5, and 5 1/5. And then I wrote them in words because to show you how you would read that. But if you we could put 2 1/5 right under this line. But the notion is to get in your mind that those are 1/5, then you have 2 of them, you have 3 of them, and you have 4 of them and 5 of them. The same thing with this. This is 2 1/4 of the circle are green. That's a mouthful. That's not something you want the kids to say all the time, are you? But I think if you keep that in mind all the time, you would say 2/4 of the circle are green, or 2/4 of the circle are green. You remember, you have to talk to your students about the quarter and the fourth and the consistency. And both are great as long as they understand that both mean the same thing. But it's just that idea that 2 1/4 of the circle are green. And the question I always ask, well, then what fraction are white? And I mentioned that every area, region, visual has 2 fractions. That's really important. And sometimes I would just say, what are the 2 fractions? Just give that circle there and say, what are the 2 fractions? So here, this is comes from a website from the States. If you've been to my sessions, you'll know that I use this quite a bit. I do like the visuals for this. It's at the bottom. It comes from Granite Schools. It's based on Marzano's research on vocabulary. The reason I like to show it is because it's a nice little visual and it will give you ideas. You are going to have whether it be a math wall or however you do vocabulary, there has to be some visuals. Maybe you use anchor charts depending on what you're doing. And these are this fraction, denominator, and numerator is good to have all up throughout the whole time you're working with fractions, because this is your basic understanding what a fraction is. It's quite small on the screen here, but it's got it showing on a number line, as a set, and as an area model, what 3/4 is, and then what a denominator is and what a numerator is. And so you might want to just show that. It's they're very open about this particular school board. I can't remember where it is. I want to say it's in Colorado, but you can enlarge them if you have the ability to do color a color printer, you can enlarge them and put them on the wall and keep them up there. Maybe somehow preserve them so you don't have to run them off every year, but so that the students can follow along if they need to. And then again, other visuals that you want to use. And the common ones where we do fractions as part of a region or a set, it's always really nice to label them all as you go along, so that the students see that each one of those equal pieces is 1/5, 1/4, and so on. And then fractions as part of a number line. We're going to talk about the number line in a few minutes. And so however you divide this up, if there's 1, 2, 3 pieces, 3 parts, sorry, or sections, then this would be 1/3, 2/3. And even though it says 1, I would always put 3/3 at the bottom. So these are just some visuals for you, and that's just getting them into the notion of what a fraction is. And here again, fractions as part of a set. I like this little one with the cats and the dogs. So there you see the 2 large blue circles and the little red, remembering that a sets have different attributes. It's how many. It doesn't have anything to do. I mean, you could ask what fraction are colored blue or which fractions are circles, but they don't have to be all the same. So the caution is, and then, so there's one with the little, I'll finish with the cats and dogs. I put this one up here because it's so obvious what fraction are cats and which fraction are dogs. But the question I have is, how can you get your students to look at more than the number of cats and dogs? So we're just generating those fractions. This is a good one for when you do tenths as well. So looking at more like what the colors, the ears, the expression on their faces, whether they're standing or sitting. And they're just so, I've enlarged them and put them on the board at the front of the room, and the kids just so enthralled with looking at them. And then you get around to looking more than at just which are dogs and which are cats. So it's a good little math talk when you're doing that. And again, I've showed you this here, the consistency to actually do this one, write the fractions the proper way, whether you're doing it on a mini whiteboard, a board, or wherever, rather than this way. And you're going to see that I've done that in a few places. So this is talking about the sets, knowing that we have 2/3 of the rectangle is shaded green, 1/3 of the rectangle is shaded white, and 2/3 of the set of counters are blue. And that's looking at the differences between the set and the region. And this one as well, but this is just as a reminder, 2/3 of the rectangle is not shaded orange. I mean, it's just reinforcing that equal pieces or equal parts. And these are other fractions. So we're looking at mass. We're looking at capacity. That particular glass is 3/4 full. It shows that. So you look at the equal parts. We do fractions. There's a cup there, which is showing that about 1/2 of that liter, that cup container is measuring cup is full, although there's a space at the top. And then we've got the distance. Okay, the length and the distance. So always, it's not just pizzas and circles and cookies like you'll see here. Okay, so let's get right into this learning progression. This is the curriculum progression. So we're going to look at the grade 4 and understand those knowledge and understanding and skills and procedures. I had mentioned to you before that not only should you look at the grade 3 prior knowledge, but within grade 4, there's going to have to be some prior knowledge that that you have had to deal with already. So when you're looking at equivalent fractions, you are going to be looking at factors and common factors when you start to simplify those fractions. And so what you're going to have to do in this right side, where it says writing a fraction in its simplest form, to prepare for that use of factors and common factors within fractions, there is an outcome previously in grade 4, which is students explain properties of prime and composite numbers using multiplication and division. That is actually a prerequisite for fractions. So my recommendation is you need to work with that and understand that particular outcome and the students before you get into dealing with simplifying fractions, because that's where the students are going to be learning about factors and common factors and greatest common factors. And they need to know that before they work with simplifying. And the same thing with fractions to to decimals. When we express a fraction as a decimal, the students should come with the learning outcome. They apply place value to decimal numbers. So we're saying here that there is an outcome where the students do work with decimal numbers, tenths to hundredths, and that should be done and dealt with before. So there's prior knowledge within grade 4 as well. Interpreting percentages is, whoops, I've got a little chat here, so I'm trying to answer as best I can. Fractions as parts of a set or ratio. Oh, yes, Sarah, they are. Yes, you can, anything can be, we can say could be a ratio. In grade 4, we're not going to talk about that, but that's well said. That's a good comment. So if I say that with the fractions as part of a set, I could say that that's the 2 blue ones were 2 to 1, 2 blues to 1 red. I could do that as well. If I even within the circle or the pizza, if I had different colors, 2 were red and 3 were yellow, I could say the ratio was whatever I said, 2 to 3. So you're absolutely right. The only thing is grade 4s don't talk about that yet. Not in the curriculum. In everyday circumstance, they may come up with ratios, but not within the curriculum. So good question. Good comment, actually, as well. Okay, so here, the first cluster that we're going to look at is we're looking at equivalency, and we're going to be looking at simplifying. So the knowledge statements, all of the knowledge and understanding are in statements. So we're looking at what equivalent fractions are. They're the same point on a number line. That makes sense, but it's not necessarily going to be fully understood. They can be created by partitioning each equal part of a fraction. I'm going to show you what that means. That just means we can take each half of our chocolate bar or our bar, and we can divide each half into 1/2, and we'll end up with 1/2 being the same as 2/4 or 2/4. So that's what that means, but I'm going to show you a visual, and we're going to talk about partitioning fractions and what that means. And then we get into simplification. So what does it mean? It can be simplified to an equivalent form, and through the use of common factors. And then when we want to simplify it to its simplest form, where you can't go any further, then we're looking at greatest common factors. And that's a lot for grade 4 students. And that's a lot for us to wrap our heads around, so that it becomes very, like I said, intuitive to us. So we know that we won't, when we work with this simplifying a fraction down to its lowest form. And what does lowest form mean? For the students, it will be, I can't go any further. This is the simplest fraction I can make. I can't make any other fraction out of that. All of that is going to have to be dealt with, and I'm going to show you some examples of what that could look like. And again, I've got this note here. Factors are dealt with in learning outcome 4 and 3. And like, if you've already taught it, great, they're going to get a double dose of it. You may have to do some learning again. And if you haven't taught it, know that the students are going to get they're going to get that experience twice. And this is where this in simplest form, exactly one of infinitely many equivalent fraction is in simplest form. Whereas the understanding at the top said, there are infinitely many equivalent fractions that represent the same number. There are an infinite number, the students have to know, that fractions that are equivalent to 1/2. And the best way to do it is just to get them to write all the fractions they can that are equivalent to 1/2. I would get them to do it in a group, and I would give them 5 minutes and then stop, and then they'll realize that they could go on forever, and they'll see a pattern. And that's really important, but there's only one that will be in its simplest form. And so what are the students going to have to do? They're going to have to model equivalent fractions by partitioning. They're going to have to determine fractions equivalent to a given fraction. That means here is 1/2. I need another fraction. What's another fraction that is equal to 1/2? Relate the position of equivalent fractions on the number line. So where is and we're gonna look at that. Those are called stacked number lines. So where what 1/2 is on one number line, where is 1/2 on a number line that's maybe divided into tenths? Where is 1/2 on a number line that's divided into eighths? Where is 1/3 or 1/4, I'll say, on a number line that's divided into eighths? So we're going to have to look at that. Identify fractions in which the numerator and denominator have a common factor. That's really, really tough. Those were all in higher grades. And then simplify a given fraction by dividing the numerator and denominator by a common factor. Now, you're working till 12ths, up to 12ths, and we're working with small numbers, and we're working with even numbers. Always, there's no remainder. That's really important. When you dealt with common factors, if you did, you knew that you would have worked with the students. They would have known that there has to be no remainders. Express a fraction in the simplest form, and then compare and order fractions. So I'm just gonna show you samples of what those could mean. Now, I'm gonna start here because this, it keeps getting updated. So this is a document that was developed by some of the people from the consortium, and it deals with the verbs. I'll go back. It deals with all of these verbs from skills and procedures. Throughout all of K-6 now, the 4 to 6 is in draft form, but all of the verbs that are dealt with in the skills and procedures, there is in math, there is a definition for them. Sometimes it's very generic. It could go for many different concepts. So what they tried to do for some of them, the ones that have the little asterisk, they made these little cards with it, and there'll be an example. So what does represent? This is the general definition of represent in math, to convey understanding through pictures, diagrams, and so on. But if it has to do with representing, let's say, fractions and decimals, when the document is finished, if that word is one of the ones that has an asterisk, it's a higher level verb, it will have an exemplar for fractions and decimals. And so you'll see that word represent having many exemplars depending on what the concept is. But it's understanding right now, what does that verb in the skills and procedures mean? And I'm just giving you some examples. So we've got the word interpret in fractions. And interpret means to use reasoning and knowledge to make sense of and draw meaning from. So when we're asking someone to interpret a fraction, that means, what does it mean when you see it? What could it mean? What could it look like? What does simplify mean? This is a very important one. So to reduce to a simpler form, fraction or expression. But you see the note that's my note. The word simplify versus simplest form, because, and I'm just from experience, I have been many years ago, I had been the exam manager for grade 6 and 9 PATs in math. And then a few years ago, I did a project for them where I had to take all the part A's for the grade 6 PAT, and I had to find all the misconceptions for grade 6 and 9, all the misconceptions, all the errors that were made. I couldn't do all of them because there are so many, but come up with the major ones and code them so that Alberta Learning wanted to know, well, what errors and misconceptions, misunderstandings do these students have in part A? And one of the biggest ones for grade 9 was the simplify. So something as simple as, if it was 10, I'll say something where I'm trying to think where it wasn't in its simplest form, but it was in a simpler form. So I didn't get it down to 1/2. It may have got it down to maybe 6/12. So maybe it was 12/24, let's say. And the student in grade 9 would say, and put the answer, because they'd ask for you'd have to add or multiply and then put the answer in simplest form. Well, they would put it in 6/12, and it wasn't correct because because it asked for it in simplest form, not just to simplify. So you need to be very cautious with that and make sure that they understand, because there's nothing wrong with 6/12. It is a simpler form of 12/24. But when they say they want you to put it in the simplest form, they want you to go right down to as far as you can. So relate is to show a connection between the two. Relate decimals to fractions the students are going to have to do, and to express. And it might be something as simple as express a decimal as a fraction, or just express an equivalent fraction for 1/2 or 2/3 or whatever. And then this word partition, where you have to separate that. And I put the word, it's not in the definitions from this glossary that you have the link to. I put the word equal in, because in fractions, you're going to partition to separate them into equal parts or equal shares. And so that's why the brackets are there. And then that little note there, it says you can use it as an anchor chart. So here, these are some of the things that are just in general, before we move on to show you some of the examples of the understanding and knowledge statements, some important things for you to know and understand. That there are different meanings or interpretations of fractions, that there are different representations of fractions. What does the denominator mean in a fraction? And those are things that we know. We can identify what the denominator is, but this question says, what does it mean? And you have to think about that and make sure that the students understand that. What does the numerator mean? How are the numerator and the denominator related? Just some things that you need to think about. What does partitioning a fraction mean, and what does it look like? You're going to see that in a minute. What does equivalence mean? What does that mean, equal fractions? Because 1/2 doesn't look like 2/4. Visually, it doesn't. It's like 0 2/10 is equivalent to 20 hundredths, but they don't look the same, but they have the same value. And that's what it means here as well. How do you determine equivalent fractions? What does in simplest form mean? What does simplify mean? What do you do when you simplify? Those are the questions that, and again, if you are think about those, you'll do them in your teaching. And then what is a factor, common factor? You've already maybe dealt with that in the other part of number. And then we look at, I put this percent in, but we won't deal with percent. We're going to deal with it at the end. So what does percent mean? Where do I see it? Where do I use it? Grade 4, we're only dealing with it as a fraction and a decimal to hundredths. They've worked with that number, and now they're going to bring meaning to that over a number over 100. And how to relate a fraction to a decimal, a fraction to a percent, a decimal to a percent to a fraction, and a percent to a decimal. But it's all, how do those three work together? How are they the same, and how are they different? So we're going to look at comparing fractions. As I go through these slides, and remember, I apologize because I don't go in any great depth as far as a teaching strategy is. It's more about what does this particular statement mean. So as much as possible, I always try to put the statement. So this one is compare and order fractions from the skills and procedures. And this is comparing fractions using the number line. And we call this stacking, but it's just putting one number line above the other because it's so visual and it's so easy for students to see. So when you have your fractions on a number line and you're going to stack the number lines, always make sure that the starting point and the end point of your number lines are always the same. That's because that's where the comparison comes. You see here that this number line, and you may, with students, maybe the first one I should have showed you is both to be fifths. That would have been a better example for you. Have them both be fifths so that you both have both number lines have 5 sections in them. And then you're doing the easy, relating or comparing 2/5 to 4/5 so that the sections are the same. But later on, you're going to have to tell them, because that is a misconception of students, that more sections means a greater number or a greater fraction because there's more parts. And we think, how could they even think that? But their little minds, they just see 5 parts. Oh, that's going to be a bigger number. In this case, it is. But I could have put this fraction here at 2/5 and it would have been smaller. So these are, you share, they're called number lines. We stack the number lines, so that's an easy visual for them to see. And I will change this one and make another one where they're both fifths. Or looking at the greater fraction here on the side, where you've got two very different visuals. So you're going to compare 2/3. Now, this is a difficult one to compare 2/3 to 3/4. I would probably have had, again, 2 glasses here with 2/3 and 3/4, and then 2 bars here with 2/3 and 3/4. And I always like to do the stacking. The glass I would do side by side, and the bars I would be stacking together. And then they're going to move into something like this. So which is the greater fraction. And then we start to look at equivalent fractions. So again, we have a visual here, a nice little vocabulary where we're looking at equivalent fractions. The reason I like this one is because this is going to get you into looking at paper folding. Nothing is better than paper folding for students to understand equivalent fractions. Now, I went very quickly through fractions with the comparing. I only showed you one slide. The idea is that you understand what that means, and then for each of the slides that will follow, I will show you some. They end up being teaching strategies, but we're looking at that equivalence again. And there's not. I'm going to go quickly through these slides, and there probably isn't as many as there should be. I'll put some extra ones in the notes I always do to send to you. But again, I'll relate to that second or part 2 of the fractions, where we'll get into some deep teaching strategies. But this is a good one. So you have this notion of what equivalent fractions is, and we start with the paper folding. This is just to give you the idea, because the students, you have these in your school. You can print them off. They're called fraction towers or fraction strips. Sometimes there's commercial ones where they're plastic and they can be put together. And that's great to have. And some students may need that. But if you want all your students to have something to build this fraction tower, or these make the fraction strips and put them together, nothing is better than paper folding. And all you need to do is to cut strips. It would be great if you could use different colors for each one of the denominators, but or the students could color them if that's what you wanted. But let the students make those strips. Just make sure that all your strips are the same color, all the same size. So there is a perfect example. These what the students did. The strips were all the same size. They were folded in half. Now, sometimes what I like to do is I like to take one strip and fold it in half, and then fold it in quarters, and then fold it again. So then in the one strip, they see how many equivalent fractions there are on one strip by all keep folding it all the time. But this is for your students at your grade. They should take one strip for each fraction or for each fold. So there's one at 1/2, 2/4, or 2/4, 3/6, and 4/8. And that's the equivalent fractions. And then they're going to build and keep going with that and go into eighths, get a strip and divide it into eighths like they showed here. And then we need to do tenths and we need to do twelfths. And what the next one will show is that it's just the instructions. If you can see the illustration, where then what the students will do is they'll tape that to a large piece of either brown paper, construction paper, maybe something that's a little bit heavier, so that now they have their own fraction tower or their own fraction strips, and they're all together. So making the strips is really important, the process for understanding. But if you want to have them keep that with them all the time, then they would paste those on or tape them onto something that has a bit of a structure to it, so that they have it with them all the time. And then they've only got their own fraction strips, and then now they're on their way to doing equivalents, to doing comparing fractions, adding fractions. You don't do adding fractions in grade 4, but they can actually do that with these, and to use that to have them talk about all those things. So now let's look at what partitioning is. This is just an example, and you're going to work with that. Actually, the fraction strips deal with partitioning as well, but I like to deal with the fraction strips just dealing with equivalence and building that fraction tower, and then do the partitioning just a little separately. So this is the knowledge statement. Equivalent fractions can be created by partitioning each equal part of a fraction in the same way. So there we have a strip, and we've got 3/3, 3 out of 3 that are yellow. what I'm going to do now is I'm going to partition each one of those thirds into 3 pieces. So now I've partitioned the third, 1/3 into 3, the 1/3 into 3, and the 1/3 into 3. I could have done it half by folding, but I chose to do 3 for this one. And now I always like to write the fraction, 9/9, or 9/9, I should say, 1 whole, which is 1 whole for each of these. And then I'm going to look at the fraction then. So I'm going to go back to the thirds, and I'm going to shade it now. 1/3 of that, the top one is now shaded green. And I'm going to do the same thing with the bottom. And now 3/9 of the bottom strip is shaded. This for you is to show you what partitioning means. Now, there are lots of ways to do that with the students, but it is taking that, looking at equivalent fractions by partitioning each equal part that you've already been given. So you've been given thirds, so you're going to, and the easiest thing to do is to take each one of those thirds and divide it into half so that you end up with 2/6 as 1/3. But that's just a visual for you to see what partitioning is. The other knowledge statement that goes with it is partitioning a fraction can be interpreted as multiplying the numerator and denominator of a fraction by the same number. And there's the visual that I've showed you there. And that's the symbolic. So we're taking that. I like to do that long line to show that I'm multiplying 1 times 3 on the top, and I'm multiplying 3 times 3 on the bottom by the same numerator, and I get 3/9. And I should have put the equal in the middle. Now, the next thing I could do is I could it says multiplying the numerator and denominator by the same number. Then you would go forth, try to do as many visuals as you can. So do the halves, times 2 times 2. And then now what would happen if we multiply the numerator by 4 and the denominator by 4, and what fraction would we get? So it's moving that visual model to that symbolic model, and looking at the pattern. But they need to see that if they do or we all do, if we do multiply the numerator and the denominator by the same number, that we do get a fraction that is equivalent. It will look different, like 3/9 and 1/3. Visually, it will look different, but it has the same value. And then we've got the equivalent fractions on the number lines. And this is, again, looking at them, what we call the stacking number lines. I took this from one of the sites that you're going to get. The important thing to remember is that we have 1 here, 1 here, and 1 here. And the sections there, whether it's 2 sections, 5 sections, or 10 sections, we still can see that we've got 1/2, and that 2/5 is the same as 4/10. And I know it's tedious, but if you have number lines, print them off for the students. You might have one across the board in the front, but they need to label those. They need to keep labeling them all the time. But this important piece is knowing that it ends with 1 and not 2 or something else. So that's just another visual for you. And then the pattern blocks. And these are I like using the pattern blocks. Some students struggle with them a little bit, because what you do is you change the whole. And sometimes that students can't quite get that. I always use the hexagon as the whole first. So that's 1 whole. And then the trapezoid is 1/2 of a whole. The rhombus 1/3, and the triangle 1/6. And we've all used pattern blocks. If you haven't got them, I'm sure the primary grades have them. I'm sorry, this beige up here, this beige rhombus should be yellow here for the hexagon. Sorry, it should have been yellow underneath. And these are not to scale. Some of them are larger than others. But the notion is that they would see that they can see here, just this visual, that 3/6 is the same as 1/2. And so how many 6 would be a whole? Of course, 6/6 would be a whole. And then by putting these green ones, the triangles on the blue, they see that this 2 triangles will make up the blue rhombus. So that then, therefore, in this case, where the rhombus is 1 whole, the fraction, the green triangle would be 1/2. You can see that as soon as you change the whole, it gets a little complicated. I like to work with just this and see that I can cover it, this one whole, with so many fractions, so many blue ones, the rhombus. So if I know that the rhombus is, there are 3 of them, so 3 rhombus will make 1 hexagon, and I know that 2 of the triangles will make a rhombus, so then I know that 2/3 in this case is equal to 1, 2, 3, 4, 6. So 2 blue ones is equal to 4 green ones, or 4, 6. And the best way to do it, it sounds a little convoluted right now the way I'm saying it, but the best way to do it is to actually put those triangles and those blue shapes and the red trapezoids on top of the yellow one, so that they can see that. Kids like to work with that. So you can do equivalency through that way. And the second session is going to do more of it. This is just an example. It came from this Mathagon site, has a really nice virtual site for you to use. So I just gave you this to show you if you want to do some work with the students, to give them a little bit of a challenge. Beginning is really easy. The question is, what fraction of the whole is not yellow? So if they know that is not yellow, so if they know that if they've worked with the pattern blocks, they will know that one of the green triangles is 1/6. And in this case, what's not yellow is 3/6, which is 1/2. And there you're working with equivalence as you go along. And that's again, you're going to see that that's 5/6. So this, you can see this is 1/6. So no matter what, this is going to be 5/6. But let them put the green ones on top. This is the third one I'm doing. Let them put the green triangles on top of the red and the blue, and they will see that 5/6 are not yellow. So bit of a challenge, something for you to work through, but it's just another way of showing equivalent fractions. This one gets a little bit more tricky because this is showing that 2 yellow hexagon equal 1 whole. And there are actually pattern blocks now, but they're pink, and they are actually stuck together. So 2 pink ones together will make a whole. And those were usually used in the junior highs. If you're in with the junior high school classes, they may have them, and they were mostly for operations of fractions. So again, you're getting this red trapezoid would be 1/4 of the whole. And then there's the site for you to go to. So just some challenging questions, but again, working with equivalency. And then we get into simplest form. So here again is a visual. What are we looking at in simplest form? And this is a really nice one. 4/8 in a fraction in simplest form has the fewest possible pieces. That's a good way to say it. It's not the way I always say it, but it gives you a further explanation. So but you have to have a visual for that. It's the fewest possible pieces. In a set, I'd have to think about that a little bit. What would that look like if I simplified it just in simplest forms with a set? So, and then here are all your statements that come from your program of studies that all deal with simplifying. Simplifying using a common factor, then the greatest common factor. We want the simplest form, and then you have to simplify it, a fraction, and express it in its simplest form. So there again, those vocabulary words are so important. And that's where that document that you have where it talks about what does simplify mean. I'm looking at my time here, so I'm going to go again. If you've dealt with factors, I'm going to go a little quicker. If you've dealt with factors already, you would have used this, or if you've been to my session on factors, this is a repeat of that slide. Just to remind you of what a factor is, remembering that if you've not worked with factors yet, or if you didn't go to my session, just the curriculum says that a factor of a number is a divisor of that number. So it's just to make you aware that we always say what 2 numbers multiplied together are the factors, but a factor is also the divisor, and the quotient is the other factor. So the curriculum is getting students to think of factors through multiplication and through division. So when we look, and then we've got the common factors, here. What is the greatest common factor? What is a common factor? Again, these are for you to look at. You've probably used them already, talked to them with your students already. And here's where they're so critical for the new curriculum. So I'm not going to go into what they are because hopefully you've dealt with them. And I will tell you, if you didn't go to my session on factors and multiples, it was a 4 to 6 session. Just give me an email. You'll get my email at the end, or you'll get it through these slides, and just email me and say you want those slides as well, because they go into it a little deeper. So here's simplifying a fraction. This is symbolic already. I'm going to. So the factors, looking at what the factors of 8 are, and I tried to keep it as a look like a fraction as much as possible. Rather than put them on the side, I like to put them beside the number, beside the numerator, beside the denominator. So here are the factors. Then again, here are the common factors. I'll work through that and put that visual if I need to. These are the common factors, and then I'll work through it again, and that green is the greatest common factor, and then they will have to divide that. And you can see I always, as much as possible, try to keep it looking like a fraction, even though that line, there's a whole statement above that. Just try to keep that look the same. So when they divide it, then they'll see that 8/12 is equal to 2/3. And to remember that simplifying conserves equivalence. When you simplify, that fractions are equal. One of them is just in its simplest form, which it could end up being, conceivably, you'll work with 1/2 a lot. Try not to work with always and think about simplest as being one where 1 is the numerator, because then the students will think that 1 needs to be the numerator all the time. So in this case, this is the simplest form, 2/3. We can't get it into a smaller piece or smaller pieces on the number line or in that strip. So try not, we have a tendency to want to always put the numerator to 1 because they're the easiest to show, but remember that that's not always the case. And then we look at decimals and fractions. Here, I think this part you will have no trouble with in understanding any of these. These are very simply put in the curriculum here. And this is, if you've taught grade 4 before, this isn't really anything new. Decimals are new for grade 4 students, but the grade 3s coming should have worked with fractions and with tenths already. And you can see in the work we did just now with equivalency, you were working with fractions with tenths. So now this is just relating, getting them to look at fractions and decimals and relating them. And we have, starting with the knowledge statements, the fraction and decimals can represent the same number. So we have 4/10. This is not written correctly. And we have 0 and 4/10. You should always try and say 0 and 4/10. As much as you can. I know it's easy to say 0.4. It really is. Try not to use the word point. If you're going to say it, say decimal point. And then they're going to realize and see that in the next one here that 0 and 50 hundredths or 50 hundredths can be expressed as 5/10. So that should be as 5/10, because 50 over 100 is equivalent to 5 over 10 through equivalency, which is equivalent to 0.5. So they're going to make that, learn about writing a fraction as a decimal, and then they're going to look at those equivalencies. And then the most important part of this, that decimals can be expressed as fraction, is that, again, 0 and 2/10 is equal to 0 and 20 hundredths. It is the same value. They look differently, but they have the same value. And then we're looking at decimals numbers that terminate, do not repeat, are fractions with denominators of 10, 100. And you're going to be working with tenths and hundredths with them. And fractions and decimals that represent the same number are associated with the same point on the number line. Exactly what we had said before. So this piece, and you can go through it, and I've got the slides after, is not, this is pretty straightforward. They're going to relate fractions to decimal, and they're going to express a fraction as a decimal. And relate means to, this one is saying to their positions on the number line. So again, you're going to do the comparison. So you may have a fraction, 2/5, and you may have a decimal, 0.5. And you're going to put those on the number line where the student is, and they're going to make that comparison. And here's a decimal and what a decimal fraction is again. And then putting decimals and fractions on the number line. So looking at this, you can see the stacked number line. Here's 8/10, and here is 0.8, and that they're equivalent. And then again, you're going to move to make a fraction. Maybe that's 5/10, and a decimal that's 0.8. And here are this is the curriculum that goes with that. So again, and here I just very simply showed you the fraction and the decimal being the same. So that's no more the student is going to have to do than relating those fractions and decimals. Here's where it's really important here. So where it's showing you, this is very simple. I did this very crudely just to show you how come these 1/2 are not at the same place on the number line. And this is where I have mentioned so many times where our endpoints are different. And therefore, our 1/2 are going to be different. And you can even do this kind of exercise with your students and ask them that question. Why aren't they at the same place on the number line? Because look at the endpoints of there. We've got something that's divided into 3 as opposed to something that's divided, a number line that's divided into the numbers, the natural numbers 1 and 2. So you need to talk about this and really be aware of that, because students will have misconceptions around that. I just missed this here. And then here's another nice little number talk. It's 5 o'clock now, so I better hurry. How would you explain this? Again, we're looking at here a very different feature where we've got a shorter number line than the other. We've got the same endpoints, but we've got, so our 1/4 or 1/4 is at a different place. Really important for you. It's something we never think about because we always, we're going to put the same endpoints. But it's just, this is a good discussion, a good math talk to have with your students, just to get over and make sure that they understand and are not thinking or worried or have that misconception of what those number lines should look like. And then these are a few other misconceptions. I won't go through these. You can look at these for students. This is the one here is just to show some students think if there's more sections that the number is bigger, even though in this case it's the same. I think I talked about that, and I really did experience that. They just assumed because there were more sections that this was going to be a bigger number or a greater number. So, and then we look at percentages, and we're looking at a fraction over 100. How do you express that as a decimal? And then anything over 100 that they're going to look at is a percentage. So they're going to investigate percentage in familiar situations, compare percentages, and then they're going to have to express the fraction out of 100, the decimal out of hundredths, and then the fraction as a percent. So if it was 5 out of 100 or 5/100ths, it's going to be 5%. Again, I've got the example here, and the base 10 block is a perfect place to show it. It's a perfect manipulative to show them. And then here I've got some slides for you that will show you the different meanings for percent. And I put this one here because this is 110%. And the question is there such a thing as 110%? And yes, there is. What's the meaning behind 110%? Do we always stop at 100? Is that the very best? Different places that, and for you to show the students where they will see percentage. There is your visuals again with your meanings. This one, I'm going to bypass this one and go in. Again, just a very simple visual for looking at the relationship between percent, fractions over 100, fractions over tenths, and then the decimal, and 2 of them. Okay, and we're looking here at equivalent fractions and changing those to percent. So a little number talk. This is a great one. We have 2 students in different grades, but one got 5 questions correct on their math test, and the other one got 10 questions correct on the math test, but they both got the same percent. How could that be? And I mean, to us, it's fairly obvious, but to students, it not so much so. Again, something for you to work with them. And then some other ideas for you to try. The Freyer model, I always love to use. It's a very good check for understanding. You can even use it for assessment purposes. And then some books that you may have in your school about open questions about fractions you might want to do with your students. And then I'm going to end in 4 minutes over. So when you get this, I apologize for being so quick at the end here, but when you get these slides, you will see, check for the second session on equivalent fractions, and it's on October the 19th, coming up this month. And that's when you're not so much the outcomes and the statements will be looked at, but just fractions in general. And you can use, there will be some work on the pattern blocks, where the pattern blocks are used differently. And then the number line again, but it'll be more things that you can do with your students rather than looking at the outcome itself. So again, I'll end with happy Thanksgiving to you, you three, you troopers who stayed till the end. And make sure this weekend you get a really, really good rest. And this went by so quickly. I spoke so fast, but you'll get the notes with the slides, so not to worry. And I will, in the chat right now, I will just put here, if you want to grab this, if you want the slides, if you didn't go to the session and you feel that you could benefit maybe, or they might be of interest to you, the slide, whoopsie, that's the wrong address. It's my other one. You might want to have the slides for the factors, primes, and multiples. I'll send those to you. Okay, so it's there. So you can take that down and then just fire me a quick email. Or if you want to say right now, because there's only 2 of you. So if either of you, I'll just write your name down because I have all your email addresses. I have to send you the slides. So if you think you might want them, okay, I'll send it to you. So Sarah, I'll send you those other ones. So you'll have a double dose of those factors. All right. So and Wendy as well. Okay. So to Sarah and Wendy, thank you so much. Conceivably, I might have even I might have even not done this recording till later. So now I've got it done.